All right, yeah, welcome back again. We are going to continue from where we left off. So we are able to collect our landmark data in two-dimensional. You can see what we actually collected, the physics spatial landmarks in for the races, the Africa, Asia, and Europe. 3 races or populations. You can use population, can use races or species, whichever one you prefer. You can use species. So now we want to go further from there and perform what is called GPA, general pro-score analysis. General pro-score analysis, which are otherwise known as superimposition methods. All right, so we want to see how we can superimpose our landmark data. So before that, we have to first call or read data set, the landmark data we have generated. We have to first read it in R. So we are going to use RStudio for now. All right. Before we are using the GUI for now, we want to switch over to RStudio. Our work more effective, easier. So now let's start by calling our library Geomorph. So let's import the library first. Library Geomorph. So let's run. Want to run? Just click on run here. You can see to show this is running. Also, we need to set our working directory to let's set our working directory. Last time we choose class, this our directory, so let's open it directory. All right, so let's run this again. Let's see. It's loading. All right, so we can start now and call our data, which we have our TPS data. So that is thin plate spline. That's the meaning of TPS, thin plate spline. So I'm going to call it now to read it out. So let's read it. Let's call it landmark. Let's use LM. So LM. All right. So we're going to read landmark. Landmark data. Read land. Here, out of TPS. I think what you are using to just select this. Then call our the name of the landmark data, and which is this what we are looking at now. So don't forget to always remember this. So we need to always do this whenever you want to call our landmark data. You want to use it, you have to read it first. It's very, very important. So without we cannot continue, not be able to do anything. So we must know the location where your landmark data is. Where you have to browse the location, and before you can go further. And then when you do that, then it will be loaded and you can use it. So let's forget that we have already copy. Let's check our folder. If we have a copy in our folder, in our directory, which we are using now. So if you have a copy there, then you can come else. It will not show in our. So let's see. None is here. We don't have anyone here. So let's bring it here now. Let's bring it here. So I have a copy here. So this one is on. So I have a copy. So let me just bring it here. All right. So we can call it now. So the name is all race. It's all race. So we can call it now. So just in column 9. Forget case sensitive, or is those TPS. Either uppercase or lowercase here, correct, for the extension. So now, other parameters that you may want to set here, if you have, for example, you have a curve along with it, you can set a curve. I mean, if you have a curve, you can set the curve. There's no problem. Just specify your ID. Specify your ID. Here you are using ID, image ID now. All right, that's what you are using now, image ID. So I mean specify ID. So there are two types of ID. There's image ID and there is a normal ID. All right, so the normal ID is what we are using now. So we are not using image ID here. So if you are using image ID, just say ID space ID is equal to image. So but if you are using direct ID from your landmark data, you just specify ID. So let's just specify ID. Just say spare ID equals to ID. So we are using this ID we are talking about. If you open our landmark data here, if you open here, you understand what I'm talking about. Look at what I'm saying. Let me open it and show you. All right, so you see now we have landmark 32. It's our TPS. You can see ID, this ID. Sometimes you can have image here also. Apart from that, image, for example, now can have image. So always in uppercase, right? Image equals to, you have a JF00.jpg. That's the image ID. Okay, so you can specify image. You can put image if you want image, but it's better you use a ID so that you can follow up with your spreadsheet format, because later you are going to separate the demographic information. You are going to separate them later for analysis, so it's better. So let's run this and see what happens. What happens? Any error? So it runs successfully. You can see we have no curve detected, because you have a curve. You'll have the curve here. So that's the way you can generate curve as well. So we should not cover under this. We say not all specify have scale adjustment. So because we don't specify scale, so it's automatic. So you can use 10 millimeter scale. It's based on your research analysis to carry out. So let's go further. So now we have recorded our data now. You can even say LM. You can say, okay, let's look at what is in there. LM. You can just say D LM dimension. Let's look at the dimension of LM and see what we got from that digitization. Well, I can just do that here. Just say LM. All right. So now look at what it's saying. It's saying 22 landmarks. Don't forget, 2-dimensional and 60 observations. Don't forget this. So you have to check this together when you finished calling your data landmark data using your rich TSP. You have to check to know if what you got actually is accurate. We must show you the landmark data, total number of landmarks. We show you the dimension. If 3 dimension, show you 3 here, but this is 2 dimension. And if it is the number of observation we show here also is 60. Don't forget that. All right. So you just don't need it anymore, so we can take it off. So now let us now do what is called GPA. GPA means, like I said before, it means general cross analysis. It is having obtained the raw landmark data for the number of specimens we want to use in the analysis or in the sample. The next step of analysis is to translate and rotate the landmarks configurations into a common position and remove size differences between them. Okay, this operation called superposition actually is it eases comparison configuration by removing variations associated with differences in their location, orientation, and size. All right, so what you want to do now is to perform that now. Let's call a GPA now. So just use a very simple a method, GPA chain, right? So we supply our landmark now, our LM space. Then we now because we don't want to be seeing the what do you call it now, the progress. So you can say print.progress equals to false. So you can do this anytime you want to, so that you don't just because no you can leave it like as a learner. You can keep seeing your progress as it generates, as it's going. but I don't want to be seeing the progress all the time. So let's see look at the difference now. Let me remove it. Let me run it and see what I'm talking about. See what I'm saying? It is done now. No progress is showing. So let me remove this now and see the difference between when the progress is there and not. Okay. All right. Let's try that and see. You can see it will either be very slow, can be very slow. Sometimes you just see the progress rate performing GPA to be going little by little like this. All right. So until it reaches 100%. Now, but I don't want to be seeing that all the time. So when I run my program, so I just I can remove that. Okay. So I don't want to be seeing the progress. All right. So that is our GPA now. What is in GPA now? Okay. Let's see what is in GPA. Before we go, let's try to type GPA. Just say GPA EFS GPA. We have done our GPA. Let's see what is inside GPA. Right. So scroll and see. Okay. We have GPA here, so let's we have our landmark data is here. All right. We have 22 fixed landmarks, two-dimensional landmarks to show iteration. Now we have consensus mean configuration now in our GPA. So this GPA now we can now further we can print out. Let's plot and see. Let's plot and see what you are talking about in GPA. So we can use two methods to plot GPA. And the first method is to say plot. Let's say plot all specimens. All right, I want to see all specimens GPA now. So your GPA name is GPA dollar. So now in GPA we have coordinates, we have sizes, we have iteration, we have consensus, we have pro CD, we have PK and sliders, and we have many more. So when you say use dollar sign, you can see all what you have beside that object or that element. You can see all you have with it. So now we have we need coordinates now, the llama coordinates. So that is what we want to do now. So we want to run that. So let's run that and see. Just click on run. You can see what you got here. So you can see further. Let's bring it up a little bit and see how very well. So after the superposition method, now what we got is this. We have what is called this superposition of landmark data, which we have done just now. So we have this particular consensus here. So this is exactly what we are looking at. We have done the GPA now, but let us see how we can plot GPAs also in different. We can just say plot. Let's say plot also plot. Just a GPA. All right. So this is another method now. You see, we got the same thing, right? You see, we got the same thing. So you can actually use a shortcut. If you supply plot GPA, automatically it will plot for you the coordinate, which we are seeing here. So if you use a plot of specimen, you plot this the same thing for you. So that is just shortcut for that. So that is our GPA for now. So we can go further in the next class and see what you can do with this landmark data. So don't forget that it is called this is a primary thing that you must do for you to continue with any other sequence of operations you want to perform on landmark data. This comes first. This particular reading of landmarks comes first. When you have done this, then you can now continue to perform any analysis on your landmark data. So thank you for watching this. We continue in the next section. You're welcome.